We're in Module 2 looking at the Novice solutions, and this is the last problem in the set, problem 10. Relatively easy problem, but had to put it in a separate workbook because we did the pivot table one and the one before, and not enough room there. So let's get out of here and get to our worksheet. Here's our worksheet. Here's problem 10. We've got two series of data, and we're interested in the relationship between series 1 and series 2. How do they move together? If one of the values in the series goes up, does the other one go up? If one goes down, does it go down? So do we see an association in the numbers that some of the numbers are very small, but together, or some of them are very large and together? It's not at all evident from this data whether that's the case. And I would suggest that by the way, we call that correlation. How is one series correlated to another? We'd like to know that, right? Because if we can observe one thing happening, then that indicates that something else will be happening. Not all correlation is positive. Some of it's negative. Something goes up, my stress goes up, my general health goes down. My pay goes up, my spending probably goes up. That's positive correlation. I've got athlete's foot during the course of the year, and I'm measuring the intensity of it, and I'm watching the price of tortillas in Mexico. There's probably absolutely no correlation between my athlete's foot and the price of tortillas. So we do that often by creating a scatter diagram. Scatter diagrams will give us that information. If you see a pattern in this is a scatter diagram. If you see a pattern in a scatter diagram that's tightly packed, either moving up or down or sideways, but they're tightly packed, then what you've got is some sort of correlation. In this particular case, we see that there's probably no correlation because this just looks like a shotgun pattern of dots. Each one of these dots in a scatter diagram is a couplet. It's one value plus another value. It's 4 and 12. Let's see in our data here where 4 and 12 is. It's this observation here, 4 and 12. And every other one also has a pattern, 6 and 12. Here's 6 and 12. All right, so let's create a scatter diagram, and we usually do that in Excel, but we can do that in Minitab also, and the Analytic Solver platform that we'll be looking at later. So let's grab the data. Let's go to our Data tab, Data Analysis. Excuse me, I was going to go to Insert, and then go to Charts and pick Scatter Diagram. Here's a scatter diagram. Here it is. Very simply provided. I probably want to put in titles, give it information about what's going on here. Here's series 2 values, here's series 1 values, but that's easy enough to do. So let me get rid of that for a second. The next question says, let's use the correlation function. Correlation, as I said before, has values from -1 in the maximum, they're perfectly negative correlated, to +1, they're perfectly positive correlated. In between is 0, no correlation at all. Like my example of my intensity of athlete's foot measured some particular way and the price of tortillas in Mexico. So the correlation function obviously is probably going to have a CO something in it. Here it is. It pops up, Correl. It says, where's your first array? Well, my first array is my first series. Hit a comma. Where's my second array? Right here. Hit a return. And you can see the correlation calculated is -0.00526. Very, very slightly negatively correlated. Essentially, there's no correlation. But if I put a trend line in this graph that kind of fits the the graph and says that this is the line that minimizes the distance, the squared distance between points, that's really the regression. I can see that. So we can add a trend line. Let's go to our chart menu over here. It was hidden. Add elements, add a trend line, add a linear trend line. There's my linear trend line. You see it's almost flat. If it was completely flat, it would be exactly 0, but it's slightly negative. It's hard to tell from this picture, but it's actually has a slightly negative slope. And here's the value. Okay, folks, that's it for the novice problems in Module 2. Hope this was helpful, and we'll see you at the advanced workbooks. That's the end of this presentation.